So in this problem, you have a wavy roller coaster. So if this is the highest point of the roller coaster, being the roller coaster released from rest, that means that at this point you have a velocity of 0, therefore you have kinetic energy equal to 0, but you have a potential energy right here, which is max, and it's going to be the mgh. Now you have the mass of the empty roller coaster, which is 500 kilograms. So at this point you could calculate, according to the height and everything else, you can have the value for this potential energy here. So your potential energy will be 500 kilograms times 9.8 times 18 meters. So this would be 88,200 joules. Okay, so, and also like we said, at this point kinetic energy is equal to 0, so if you add them up you have a mechanical energy which is 88,200 joules, which is constant throughout the whole railing here, throughout the whole roller coaster path. So now the question is 1/4 F I guess 1/4 of the potential energy. Where is going to be? Well, because the height is 18, right? You got to do 18 divided by 4 in order to have the 1/4 of potential energy, because mass doesn't change, g doesn't change. The only thing that changes is h. So 1/4 h is going to be right here. So a point G, right? You are going to have this 1/4 potential energy. Then 1/2 of the potential energy, where would you find it? Again, the equation is mgh. The only thing that changes is h, so h is half of the value here, a point E. 1/5 instead of the total energy. Well, so the total energy is 88,200 divided by 5 is going to be 88,200 divided by 5, so the value should be 17,640. So choice 1 is you go all around and you calculate where the value is for, because he wants to know the locations. So where the value would be for the place where the total energy is going to be this much. So now which one would this place be? Here you have the mgh constant, right? I mean the max value. Here you have no kinetic, you have no potential energy, so the value of your kinetic energy is 0, so the total value of energy is going to be all potential, but it's the same value everywhere. So basically, can you find a place where the total energy is going to be 1/5 of the original? Well, nowhere, right? Because total energy, we said, is constant anyway, is always conserved, so there's no way that you're going to lose 4/5 of the energy anyway. So this calculation, if you go through this, is just not relevant. 1/3 of the potential energy. Now this is different, right? Because 1/3 of only potential energy you can do, because that means that the rest of the energy is going to be converted into kinetic. So where is 1/3 of potential energy? Well, where the height is 1/3. So 18 divided by 3 is 6. So the point F is going to be that value. Greatest potential energy, well, is going to be here at the max height, right? So it's going to be at A. Kinetic energy equal to potential energy. It has to be where you have 1/2 of the potential energy has been converted, so the other 1/2 has to be kinetic. So only at this point those two values are going to be the same, so point E would be it. Where's the kinetic energy max? Well, it's going to be here, the point C, because it's the point where you have no potential energy at all. Lowest possible kinetic energy. Again, it should be at A because it's 0. You cannot have less than 0. Highest possible total energy. Total energy, again, is everywhere. So energy is constant. So don't be fooled by those kind of questions. Energy is constant everywhere. Okay, then number 10. Will the roller coaster stop at the top of the second hill? The second hill is here, so no, there's no way you can stop because we'll have one half of the potential energy, but the other half of the energy, yeah, and the other half of the potential energy is going to be converted into kinetic. So if it has kinetic energy, the roller coaster is not stopped. Okay, so and you will answer all that. If the first hill of a coaster instead is 20 meters and there are no frictional forces, so this means energy is conserved, total energy is conserved, how high can the next hill be so that the roller coaster comes to rest at the second peak? Okay, so the first hill is 20 meters. To be honest, I'm not sure what I meant, because if the hill is 20, okay, I can calculate potential energy here, but obviously, so probably if we are assuming that it was starting from rest, then the height of the second peak has to also be 20. So you can say 20 meters if starting from rest, because you wanted a rest at the second peak also. So if it was a rest at 20, then it's going to be a rest also the second time it goes to 20. Otherwise you can't solve it because you don't have the velocity which the roller coaster was going. Then for the coaster on the front, calculate and give numerical answers at the top of the hill that is height 19 meters. So again, this is your MGH. So it was 500 kilograms times 9.8 times 18, and we said that was 88,200 joules. What is the kinetic energy here? 0. So velocity is 0. What is the total mechanical energy? 88,200 joules. Then at G, the bottom of the first hill, okay, that would be C. Now we get the, oh man, why do I write this stuff? So for G or C, what do we go for? Let's say that this is G, but it's not the top of the first hill, okay? So what's the mechanical energy at that point? Well, without even thinking about it, mechanical energy is always the same, okay? So if this is referring to the same roller coaster, okay, so you can go ahead and just fill in the 88,200 joules everywhere you see a mechanical energy total, right? Then, so LG, what is the potential energy? The height is 4/5, which is 1/4 of the potential energy. So this is going to be just 1/4 of their number. Okay, divided by 4. So this is 2205. 22050 joules. Okay, so what is the potential energy? Well, if this is 1/4, then this is 3/4 of the whole thing. So 3 divided by 4 times 88,200, 66150. Obviously, if you add those two numbers together, you should have 88,200 again. 150. So you can do that plus 22050, and you have 88,200. So what is the velocity at this point? So if the kinetic energy is going to be 1/2 mv squared equal to 66150, then velocity at this point is going to be, so 66150 times 2 divided by 500 and square root of the answer, so 16 meters per second. Then at point C is the bottom one, so you have no potential energy. Kinetic energy is going to be again the same value. Remember, those two numbers added together has to give you the mechanical energy total. Okay, so what is the velocity instead of that point? So again, you have 1/2 mv squared equal to 88,200. So velocity from there is going to be 88,200 times 2 divided by 500 square root of your answer, 18.8. So let's do 19 meters per second. Point E, where's point E? Oh, there, 1/2 of your potential energy. So potential energy is going to be half of it, so it's 4410,100 joules. Okay, so this is E. Oh, sorry, E is 1/2. Yeah, that's what I said, 1/2. So the other 1/2 has to be potential energy. And velocity, again, when you add together, you got to have that number there. What is the velocity? So 44100 times 2 divided by 500 inverse, no, whatever. So 13.2, so 13 meters per second is going to be the answer for that one. Now, if a group of workers can work to change the energy of a car from 300 to 500, how much work is supplied? What work is the change in energy? So how much work do you have to do to bring 300 to 500? Well, you have to supply 200 joules. So 300 plus 200 joules has to give you 500. So the work is going to be 200 joules, because it's going to be basically your 500 minus 300, which is the difference in energy. And then for those problems instead, so you have this man, you have the mass, you have velocity is going full blast against the wall for some reason. So what is the gravitational potential energy? Well, this is mgh. So this potential energy is 0 because you have no height from the ground. What is the kinetic energy? Kinetic energy instead is 1/2 mv squared, which is your 75 kilograms, and then 6.4 squared, which is the meter square there. So this is going to be 75 divided by 2 times 6.4 squared. So this is 1536 joules. What is the total mechanical energy? Well, mechanical energy is going to be both potential and kinetic. So potential is 0, kinetic is the number, so this mechanical energy is going to be this value here. Then what is the momentum of the man? Well, momentum is equal to mv, so you got to multiply 75 by 6.4. Then how is the man? The man is now hitting the wall. With which velocity does the man hit the wall if he traveled this much distance with this much acceleration? So this is the initial velocity with which the man was traveling, so this is the initial momentum. Then the momentum at the moment of impact, okay, is going to be mv. What am I saying? It wants to know the velocity of the impact, so you can use the third equation, right? So you can do this. because this is your delta x. So this final velocity is going to be equal to 6.4 squared plus twice 0.5 times 153, and then you got to take the square root of this. So this velocity would be, so first of all, 75 times 6.4 is 480 kilograms meters per second. This one instead is going to be 6.4 squared plus 2 times 0.1, which is actually 1, times 153, and then square root of this is going to be 14 if we round up, meters per second. And then how long does the man take to hit the wall from the moment of in total, I guess. So this is the distance, so you can use second equation, and you have this equation in place. So your t is going to be b final minus b initial over a. So it's going to be 14 minus 6.4 divided by 0.5. So 14 minus 6.4, so twice as much. So this is 15.2. Am I right? Seconds. So what is the new momentum now? So the new momentum is going to be again mv, but now you have the same mass as before, but you have a velocity of what was it, 14. So 75 times 14 is going to be 1050 kilograms meters per second. What is the kinetic energy? Well, 1/2 mv squared. So it's 1/2, and then 75, and then 14 squared. So 75, 14 squared. So this is 7350 joules. What is the gravitational energy? Again, there's no gravity. I mean, there's gravity, but there's no gravitational displacement, I should say. So this is equal to 0 joules. What is the difference in kinetic energy of the man? Well, you have a value of 7,000 and whatever, and a previous value of 1,000 whatever. So the difference between those two numbers, so 1536. 1536. Okay, so final instead is this. So final minus initial is going to be 7350 minus 1536 is going to be 5814 joules. And how much work was done to bring the man to this kinetic energy? Well, if you're starting with this energy and you're ending with this energy instead, right, then this means that to this energy you got to supply this much extra energy to go to the number. So you got to do this much work to push the energy from this value to this value. So the work is exactly that number, because remember, work is how much and work is anything that makes you move from one value of energy to the other. So and you move through this to this through this value here. If now the man's nose gets a gradient by hitting the wall with the last velocity, so the 14, what is the change in momentum? Well, so change in momentum is P final minus P initial, so final is 1050. The other one was 480. So 1050 minus 480, you have a 750, this number here, 570 kilograms meters per second. And then he receives this much wall, with this much, It's going for, this is final, right? Final is this one. So final minus initial. So this is negative, which is fine because this is how much this momentum has changed. So it has lost momentum by this much, right? So now remember that you have delta P equal to F delta T. So delta T is going to be delta P, which is negative 570, divided by a force which is exerted by the wall. So it is in that direction. So this is negative 650, 620. Boys, if I'm making any mistakes on the calculations, please take care of it, right? So this is 0.9 seconds. And obviously let me know that I screwed up some calculations. So a rubber bullet, okay, is inside the Nerf gun, blah blah blah. So I'm asking you to use exactly the same equation that you learned. So even though the equation is for potential energies mgh, so in this case just use the same acceleration as if there was the gravity, and the distance is going to be this one, right? Because you have your gun, the spring is going to be compressed, and this is the bullet stuck there by the locker mechanism, right? So this compression, okay, of the spring is 0.10 meters, okay, and the bullet has this mass. So if the potential energy has that weird expression, which again would be nice if you write it MAD, acceleration and distance, and then use those values that I have given you, because in reality I should have given you the acceleration for this bullet. So this is the mass times this acceleration and times this distance here, okay, and you will have a value of 0.045 times 9.8 times 0.1, okay, this is 0.0441 joules. What is kinetic energy before being fired? Well, there's no kinetic, right, because velocity is 0, so kinetic energy is equal to 0. What is the total mechanical energy before being fired? Mechanical energy is the sum of potential and kinetic. Potential is that one, kinetic is 0, and then now the bullet is fired after the spring is completely extended, which means you don't have any more constriction of the spring. What is the total mechanical energy? So mechanical energy is still conserved, so it's still the same number. Then what is the kinetic energy when it leaves of the bullet when it leaves the gun? But because mechanical energy is conserved, and because there's no potential energy anymore, because you're not storing the energy, the spring is not compressed anymore, so the kinetic energy, the total mechanical energy basically, right, is equal to kinetic and potential, but there's no potential, so this value of mechanical is all converted into kinetic. So we said it was 0.0441 joules. And what's the velocity at this point? So this is your 1/2 mv squared equal to 0.0441, and the bullet was 0.445, 0.045 v squared equal to 0.0441. So at this point you can just solve for velocity. So this times 2 and then divided by 0.045 and square root, and you have a value of 1.96 meters per second. Direction, because final momentum is 0, because the nose of the man is according and is actually stopping, so final momentum is 0 minus initial momentum, which was with the velocity of impact against the wall. So it was this one, 1050. So when you do the subtraction, you have this number, and then at that point is fine. So you divide by the 620, you have a seconds, a time of 1.7 seconds. Okay.